All right, going back to a stochastic matrix. Again, you have a probability matrix. P is going to be stochastic if the matrix is square, also if the entries are non-negative, and we have the sum of probabilities for each column to be 1. And there are two types of stochastic matrices. Okay, one type is going to be the regular stochastic matrix and the other not. And for what we have in the case of taking what we have for a stochastic matrix, okay, so you have a stochastic matrix is going to be a regular matrix if you have what is given P is going to consist of only positive entries from the probabilities from P of 1, 1 to P of n, or if you have a raised power of that matrix to consist solely of positive entries. And let's say that just looking at whether we have the following to be regular or not. And we have, say for the first case, all right, so you have the stochastic matrix P, and you have consisting of 0.7, 0.3 in the first row. Second row we have 0.3, 0.7, and we have a square matrix. And notice that all the entries are positive, so there's no zero value. And again, we have all the entries are positive. So this is going to be a stochastic matrix that is also a regular matrix. Now we have in the next case, right, say we have stochastic matrix consisting of 0.7 and 0 at the top. And we have in the second row, we have 0.3 and 1. Now we have a zero value, okay, but this could still potentially be a regular stochastic matrix if we can raise the power, okay, of this matrix, okay, to where we have the entries to consist of only positive terms. However, if I square out, okay, I have like 0.49, 0.51, and the 0 in the upper right hand corner stays. And what's going to happen is that, okay, the zeros that we have in the raised powers, those are going to be locked in. And so for what we had, there is no arrangement where we have exclusively positive entries throughout. Okay, so the second case, we do not have a regular stochastic matrix. And then we have for P, again, we have 0.7, 1, 0.3, and 0. Now for the arrangement, I inverted the 0 and the 1, where I now have 1 at the top, 0 on the bottom. And to see if I can take a raised power of this matrix and see we have exclusively positive entries. And guess what? First column we have a 0.79 and 0.21. Second column we had changing over from 1, 0 to 0.7 and 0.3. And so with the raised power of P, this time consisting of only positive values. Okay, so P is going to be a case of a regular stochastic matrix. And we have next, we have a 3 by 3 matrix. And we have for these numbers, okay, I have 0.65, 1, and 0.8. Middle row, I have 0.3, 0, and 0.1. And the last row, I have 0.05, 0, and 0.1. And to see if this is going to be a regular stochastic matrix, so if I were to say square out, guess what? I end up with positive values throughout. And the zeros we had in the middle, okay, they have now been changed to 0.3 in the middle row and 0.05 in the last row. Okay, so since we have at least a raised power that consists of solely positive inputs, okay, it turns out that this is yet another case of a regular stochastic matrix.